Okay, so we were discussing the solar water heating system. So it's similar if you want to the previous system, but in the previous one we said that we can circulate air in case we need to use let's say heating and ventilation application. And here we can use solar water heating for heating water for domestic needs. So the system is similar. We have the components are a pump in order to distribute water within the system. We have a collector that should store the solar energy during the day. This water will, after being heated, when it passes through the collector, which will constitute like a heat exchanger between the solar panels and the water that is circulating within it. And then this water will go through a storage medium where it will heat let's say water present in a certain storage tank. And now depending on the need, we have like a control system that can circulate water towards the floor, for example, if you want to use underfloor heating, or it can directly supply it for domestic hot water need. So we can see here that domestic hot water has several applications. We can use it, for example, if you want to use it as just using a passive system, you will replace the pump by a thermosiphon block. What we mean by thermosiphon block, it will rely on buoyancy effect for circulation of water. So just you have in this system, you just rely on temperature variations that will create density variation. And this is why you need to you have here like a certain inclination allowing the water to circulate within your system. So as the water will enter the PV's array, okay, it will be heated, and due to heating effect the density will be reduced, and then you have motion by buoyancy effect. And in this case you don't need a pump, but of course this is restricted to maybe a single story building. Whenever you have several floors or you want to pump the water for long distances, you cannot rely on just a passive system. You need to use an active system, and then you just have to put a pump. And if you use the pump, you can distribute this energy, for example, directly for direct use of water, or if you don't need it now, you can just store it in a reservoir. And this reservoir will be controlled with valves, and whenever you need to use the water, you can operate your valves. So here we can see that you have three ways you can go to the, let's say, to a storage tank, or it can pass by a certain heat exchanger in order to heat water, or you can use it directly. So it depends on the need that you have. Now, another important use of solar energy is underfloor heating. So in this case, as we can see in this figure, water that will pass through the PV arrays will be heated, and it can be used in addition to other applications. It can be circulated underfloor. In this way, it can play a heating effect. And it's widely used, especially in Europe, for heating applications. We can use renewable energy to create heating of the space using underfloor heating. But of course, you need special installation under the floor that will allow you to benefit from the solar energy to heat your space.
Professor,
Yes.
how can we benefit from the solar energy to heat the water under the floor? How is it done?
Great. It is done in the following way. You put pipes, okay? You install pipes under the floor, okay? And then if you want, it's like the concept of a heat exchanger. So first, your water will circulate through the PV panels, okay? Once they circulate through the PV panels, so you have first, let's say, the blue lines are for cold water. Okay, so the cold water will enter the PV panels. It will be heated. It will exit as hot water, as you can see here in red. So now hot water can be distributed or to a it can be stored in in a storage tank, or if you need it now to be used for heating purposes, you can circulate them through the ducts that are located under the floor. So it will circulate within these ducts that are implemented on the floor. Okay, and then you have the thermal mass that is in contact with these embedded ducts will be heated, because you have the hot water is characterized by a relatively high temperature, so it will be, the temperature of water will be larger than the temperature of the floor. And in this way you will have by convection first, because water is circulating, it's a fluid. By convection effect, it will release heat it will go from the outer surface of the ducts towards your floor. In this way, you can create a relatively high temperature for the floor that, of course, it should not exceed the comfort temperature. But you know, in general, that during winter, whenever you walk on the floor, it's cold. So to avoid this cold sensation, you can put the ducts under the floor. It will increase the temperature of the floor, and once you create a temperature that will allow thermal comfort, high temperature of the wall first will allow you to feel comfortable if you touch the floor. Plus, by convection, it will heat air within your room, because if you ensure a relatively high temperature at the floor level, it will be larger than the temperature of your inner space. Then heat will go from the floor towards the inner space by convection. So you can heat your space in this way. Okay?
Yes.
Any other question on this? Okay.
No.
Now, we have several types of solar water heating systems, and depending on the application, we select the appropriate one. Okay, so first we can use unglazed collector. Unglazed collector are not characterized by a very high efficiency, but they represent the advantage of being simple to install. They have 3 to 6 year payback period. This is a big advantage because since the initial cost is low, you can ensure a relatively low payback period, and they deliver 2 to 2.4 kilowatt hour per meter square per day. The amount, it's true that the payback period is small, the installation cost is small, but also the power delivered is not very large. This is why they are restricted to applications that does not require a high amount of heating. For example, that can be used for pools. Okay, so pools to heat water in pools during winter, you need a certain amount of energy. Unglazed collector represent a very good option for heating the water of pools, because you don't need to heat for a very large temperature. On the other hand, if you want to use a system for heating water to use in shower, you need to reach a much larger temperature, because for shower we should heat up to a high level to kill a certain bacteria. So this will allow to have a healthier water. So we need to reach a much larger temperature. This is why we don't use unglazed collector for shower applications. Other types is the glazed flat plate collector. So what is the enhancement here is we put like a glazing on the top of the collector. This will enhance, if you want, it will trap the solar energy. So if we have a high transmissivity for this glass, your energy will be trapped between the glass and the ducts, and this will allow more efficient heating of water circulating in the ducts. Okay, so this system will allow larger values of larger heating loads. Okay, and the most efficient system is the one consisting of evacuated tubes. The evacuated tube design is as follows. We use concentric tubes. Okay, so first you have an outer glass tube that will trap a high amount of solar energy. So this is common to the previous system. So you have a glazing. Putting a glazing will enhance the efficiency of the system, because you have trapped energy within air here. Okay, so you can this will lead to higher energy transfer to your system. Here we don't use only an outer glass tube, we use also an inner glass tube to enhance the trapping effect. And you have a fluid tube where the fluid will circulate, and the evacuated space also will help you into trapping more energy. So this concentric design will optimize, if you want, the storage and the transfer of solar energy to the fluid, and it will lead to much larger heating power. But of course, the cost will be much larger. Okay. Now, here we can see a solar domestic hot water system. So as we discussed before, this system consists mainly of a pump, solar collector, a heat exchanger. And here also, we are putting a backup system, which can be gas or electric water heater, in order to supply the needs whenever the solar energy is not enough. Okay, so it's always advised to have a backup system in order to supply any extra need, or if the solar system is not working appropriately during some days of winter, you can rely then on the gas or electric water heater. So there are seasonal variations in the energy collected depending on the location, collector efficiency, collector angle, and orientation. So the energy can range from 0.6 to 1 kilowatt hour per meter square per day in winter, up to 2.4 kilowatt hour per meter square per day in summer. It is easy to get 50% of hot water energy from the sun. This is why, to supply the remaining part, we should have a backup system. These systems are easily integrated into current hot water systems and have a payback period in the range of 10 years. The payback period is not very encouraging. 10 years is relatively large. This is why we are trying to enhance, come up continuously develop technologies in order to reduce the payback period. And now we were able to enhance a lot. Until now, we have continuous improvement in such systems, which will reduce the payback period. So here we can summarize, if you want, the different types that we discussed together. The different types of collectors using solar energy are the unglazed one, which is it's the less efficient one, but on the other hand, it's characterized by a much lower cost. The glazed one is the intermediate one with higher heating load compared to the unglazed one, but the evacuated tube will represent the best performance. So you can see here the increase in energy delivered annually in kilowatt hour per meter square, but also this is in parallel with the increase in cost. So this is why, depending on the application, so in case you don't want a high energy, you will use, of course, the lowest cost. And in case you need to provide high energy amounts, then it's worth to have a high cost, which is the one for evacuated tube. So the typical use of unglazed collector is swimming pools. The advantage is that we have high economy, and it's this system is very efficient at low temperature differentials. So for swimming pools, you don't want to heat to a high extent. This is why this system is highly efficient. Now, the disadvantage is that it cannot be used for freezing temperatures. So because you have the risk of freezing water, so you should pay attention in very cold conditions. The system cannot be used. Concerning the glazed system, it's used in general for domestic heat water. It has the advantage of being economical compared to the evacuated tube, and also you need to provide protection from freezing. So this is common disadvantage with the unglazed type. The capital cost is intermediate, and also the energy delivered is intermediate. Now, in case you need to reach higher values of higher heating loads, so let's say you want to use underfloor heating, you can go to the evacuated tube option because it can provide hotter water, but on the other hand, it's expensive and also it needs protection from freezing. So depending on the application you have, you select the appropriate system. Now, in the following figure, we can see the variation of efficiency of these systems with temperature. One of the main advantage of evacuated tube is that the efficiency of this system will not be decreased with high temperature. In general, one of the most challenges that faced the technological development of PV cells is that they cannot sustain overheating. So whenever you have high temperatures, the efficiency of these systems will be reduced. This is why we worked a lot on enhancing if you want these systems by doing what we call the heat recovery. So we can pass by a certain fluid to reduce the high temperature of unglazed type, and this will lead to enhancing the efficiency, because first you will reduce the temperature of the unglazed system, and then the efficiency of the system will increase, plus you will benefit from the heat lost from the unglazed type by circulating a fluid that can be used for other heating purposes. So this is what we mean by heat recovery. We take an unwanted heat to use it another somewhere else. But since we cannot allow, if you want, the limit here for unglazed types, the limit is 50 degrees, which is really small. So whenever you want to heat water for a larger extent, you cannot use the unglazed type. You need to go to glazed or evacuated tube in extreme temperatures, where you want to heat up to 140 degrees, for example. You can see that evacuated tube will maintain a good efficiency larger than 50%, even for a temperature of 140 degrees. While if you want to use the glazed type for 140, the efficiency will drop significantly. So in any application where heating to a high temperature is required, you go to the evacuated tube option. Now, so concerning the design procedure, so after the different issues that we mentioned, whenever we want to go to the design process, we should make sure to define the required data about building and climate. So because it's needed to be able to calculate the heating and cooling loads, we should determine if it's possible to obtain enough collector area. This is a very challenging aspect, especially when we talk about high buildings. So whenever we have several floors, in general, the roof is one of the most appropriate locations for use of PV arrays. And since the roof is common for all of these floors, so you have limited area. This is why in some buildings, they try to implement the PV arrays to the facades, okay, in a way to not, of course, to not compromise the aesthetic behavior. And they try to have nice designs of PV arrays that we can put on walls in order to trap the solar energy. But of course, a roof is more efficient, because as we discussed before, we should study appropriately when we want to put them on facades. We should put them in a way, in an orientation to trap the sun rays. Another issue is to determine the ventilation rate through the solar air collector. So we need to optimize the mass flow rate that should circulate through the system in order to optimize, let's say, the energy storage and the energy distribution. We should determine if there are restrictions on inlet temperature from ventilation system. So sometimes, let's say if you use air heating, which is the system we discussed before, you need to see if there is a certain maximum temperature you can reach. So you should avoid, let's say, having an inlet temperature that is larger than needed, or in case you have cooling application, if you should not go below a certain temperature. So you should know what are the limits for the temperatures that you should supply. We should investigate if it's appropriate to include storage in the system, and to define the required control strategy. In addition, we should choose a solar collector that is appropriate for our application. So let's say for swimming pools, we use the unglazed type. For applications needing very high temperature, we use the concentrated type. In addition, we should investigate if the system can serve other purposes. So sometimes we can, with the same system, we can use underfloor heating. We can use at the same time heating of domestic water, etc. After this, we should determine what is the required collector area to serve our building. We should size the ducting, select appropriate fan, and choose the diffusers. So we can have an overall design procedure whenever we want to design a solar system. Now, photovoltaic PV systems are, as we discussed before, okay, is a technology that is under development. And it consists on the following. When sunlight will strike a photovoltaic cell, electrons in a semiconductor material are freed from their atomic orbits and flow in a single direction. So we can convert solar energy to electric energy. This will create a direct current electricity, which can be used immediately, converted to alternating current, or stored in a battery. PV cells normally have a lifespan of at least 20 to 25 years. However, they usually last longer if we avoid frequent overheating. So as we mentioned before, we should not exceed temperature of 70 degrees. This is why we can use a heat recovery system in order to avoid overheating of these cells. PV systems can be used as a building sole electricity supply, or with other sources such as a generator or a grid connection. Now, a photovoltaic PV system consists, as we mentioned, in a semiconductor material that converts solar energy directly into electricity. Autonomous PV systems will use battery storage. Also, we can use hybrid PV systems that have at least one additional electricity source, such as fuel-fired generator or a wind turbine. We can also connect PV to the grid. So this will cancel out the need for on-site generators and batteries, and will eliminate the problem of intermittent solar energy. So if we use smart grids, we can connect this system to the national grid. Now here you can see that PV systems can be installed not only on roofs, but as we discussed together, we can use them on the wall facades. If we discuss the advancement in technology, in 2013, a scientist found out that they achieved a new world record for the conversion of sunlight into electricity using a new solar cell, for which the structure is constituted of 4 solar subcells. In this way, we were able to, after competition, we were able to reach 44.7% efficiency compared to much lower efficiencies before. So as we know, and as we discussed, advancement in technologies and research will always lead to new systems and higher efficiencies. And as we mentioned, heat recovery is one of the main solar technologies, because it will allow us to enhance a lot the energy efficiency. Whenever we do a heat recovery, we can enhance a lot the efficiency of a certain system. So we can use it from any hot process. We can design a heat exchanger that will allow us to benefit from the excess of heat, and it will be used in other plant in order to use this heat in a certain useful way and increase the overall efficiency of the system. For example, it can be passed within a condenser in a boiler. We can use exhaust gas in a heat exchanger. This is called the cogeneration process, and we can reach efficiencies larger than 100% because we are we can use to the maximum the energy delivered from such systems. So this is the end of this chapter. In this chapter, we discussed a lot of strategies that will allow us to reduce the energy consumption. Now, after tackling the different aspect of energy consumption, we are ready to move to next step. The second part of this course will focus on economical tools in order to assess, if you want, the economical feasibility of a project. So we can do economical analysis in order to decide if any scientific innovation is worth to go with or not. Any question before we stop? Thank you. Bye-bye.
Professor?
Yes?
We wanted to discuss with you the topic of our project.
Yes, sure.
Is it possible?
Yes, sure.